Hello students, today we are going to discuss another important topic, that is electrochemical series. Electrochemical series. So electrochemical series is arrangement of the elements starting from F2. F2, here it is given reduction. So F2 will accept 2 electron to form 2 Fe minus. At that time, what is the electrode potential? Standard reduction potential E0 value is equal to 2.87 volt. Then a number of elements will come. Then H2, 2H plus will accept 2 electron to form H2 gas. Its standard electrode potential is equal to zero point 0 volt. Okay, 0 volt only. Then at the last you can see Li. Li plus will accept one electron to form lithium solid, right? And E0 value is equal to minus 3.07 volt. 3.7 volt. Yes. So, what is the meaning? Okay, what is the meaning of this equation? So, it's very important for Neet and your CBSE exam. All the exam, it is very important. So, listen carefully. So, its meaning is fluorine F2 gas want to become F minus ion. F minus in the aqueous state. That means F minus is the most stable state. F minus is most stable state than comparing F2. So F2 want to become a reduction. F2 want to form reduced form. That means you can tell F2 is very good, strong oxidizing agent. Strongest oxidizing agent because it want to undergo a reduction. Or you can tell that it having very high oxidizing power. Oxidizing power. It having very great strongest oxidizing agent. It having great oxidizing power. Yes. Then what about F minus? You can tell that F minus is the weakest reducing agent. So F minus is weakest reducing agent. Okay, right? So reducing agent means oxidation, right? It don't want to undergo oxidation. Similarly, Li plus when becoming lithium atom, when it undergo reduction, it is minus value. Negative means it don't want to undergo oxidation. It don't want to undergo reduction. That's the meaning. Negative means it don't want to undergo reduction, but it want to undergo oxidation. It want to undergo oxidation. That means Li plus is the strongest reducing agent. It's the strongest reducing agent, or you can tell that lithium is the weakest. Lithium atom is the weakest oxidizing agent. Okay, Li is the weakest oxidizing agent, right? So how can we conclude? How can we conclude? So we can conclude that if positive, if reduction potential is positive, comparing on its higher value, okay, reduction potential is positive means it will undergo reduction, and the substance is acting as good oxidizing agent, right? Now we will discuss last 24 years, okay? Now we can discuss last 24 years of questions. So note down the question. This question was asked in 2019. Okay, 2019. The question is the standard electrode potential, that means E0 values of Al3 plus Al Ag plus bar Ag K plus bar K and Cr3 plus bar Cr are minus 1.66 volt, 0.80 volt, minus 2.93 volt and minus 0.74 volt. Although respectively, the correct decreasing order of reducing power of metal is. So this is a question. Options I am not giving because it will consume a lot of time. So I am only discussing the answer. So here standard reduction potential values are given. You have to write the decreasing order of reducing power. Okay. So take that point, reducing power. So reducing power, which is equal to reducing agent. Reducing agent. So reducing agent means it will undergo what? Oxidation. It will undergo oxidation. So which is the strongest oxidizing agent? Which having very less reduction potential, it will act as the strongest reducing agent. So more negative, more reduction, more reducing agent. Okay, so more negative, strongest reducing agent. You see, which is the yes. So this is the lowest value, minus 1.66, 0.80, minus 2.93. So higher negative value is less value. Okay, that also you should remember. High negative value is equal to less value, low value. Okay, so high negative means a very less value. So which is the very less value? Minus 2.93 volt. So which is corresponding to 1, 2, 3, third one, that is potassium. So potassium will come decreasing order. So potassium, this is the strongest reducing agent. Then which is coming minus 1.66 volt, that is aluminium. Then third one, that is chromium. Then last one, Ag. So this is the decreasing order of reducing power. Reducing power means it's an oxidizing agent. Okay, oxidizing agent. Then the next question, Second question, this is asked in 2013. Question is, a button cell used in watches function as follows. Zn solid state plus Ag2O solid plus H2O. Liquid state gives 2Ag solid plus Zn2 plus 2OH minus. If half cell potentials are Zn2 plus aqueous form plus 2 electron gives Zn and its C0 value is equal to minus 0.76 volt and Ag2O solid plus H2O in liquid plus 2 electron gives 2 Ag plus 2 OH minus and E0 value is equal to 0.34 volt. Then the cell potential will be right. So here two reactions are given. You know what is the cell potential. How will you find out cell potential? E cell is equal to or E cell is equal to or E0 cell is equal to E0 of cathode minus E0 of anode. So what is the cathode potential? So which is comparing which is higher value, that will undergo reduction, that will act as cathode. So here which one will act as cathode, which is higher value? This is negative value. So this is less only. So 0.34 volt, that only higher value, right? So 0.34 minus anode minus 0.76. So don't forget to give minus here. So minus into minus plus, it will form 6 plus 4, 0, 7 plus 3, 10. So 1.10 volt. Okay, this is the right answer. Okay, this is the right. Very simple to find out the E cell. E cell or E0 cell is equal to E0 of cathode minus E0 of anode. That is, two equations are given means which is less value, it will be anode value, and which is a higher value, that is the cathode potential. Yes. Now the third question. So this question is asked in 2012. Okay, the question is standard reduction potentials of the half reactions are given below. F2 plus 2 electron gives 2 F minus and E0 value is equal to 2.85 volt. Second one, Cl2 plus 2 electron gives 2 Cl minus and E0 value is equal to 1.36 volt. Br2 plus 2 electron give 2 Br minus and its E0 value is equal to 1.06 volt. Then I2 plus 2 electron gives 2I minus. E0 value is equal to 0.53 volt. Right? The strongest oxidizing and reducing agents are. So this is the question. So which is the strongest oxidizing and reducing agents? When they will give the four options, F2, okay, F2 is the strongest oxidizing agent and Cl2 is the reducing agent, or I2 is the strongest reducing agent and Br minus is the oxidizing agent, like that. So which is the strongest oxidizing agent? So oxidizing agent means what? It will undergo reduction. So which will undergo reduction? Which having highest value, that will undergo reduction. So which is the highest value in this? This is the highest value. So this is the value for F2. So F2 is the strongest oxidizing agent. So understood or not? So very simple. Highest value. Highest value is the strongest. So which one having highest value? It is acting as the strongest oxidizing agent undergoing reduction. Then next question, which is the strongest reducing agent? Which is the strongest reducing agent? So reducing agent means it is undergoing what? Oxidation. Oxidation. So here oxidation is given or not? All are reduction process only, right? So from this you can tell that this is the weakest oxidizing agent. I2 is the weakest oxidizing agent. From in this four, I2 is the weakest oxidizing agent. That means I minus. I minus is the strongest reducing agent. So reducing agent means it will undergo oxidation, right? So this is the right answer. F2 is the strongest oxidizing agent and I minus is the strongest reducing agent. Okay, not I2, it is I minus. Okay, so to take care of that one. Then next question, fourth question. Standard electrode potential potential potentials of three metals three metals x comma y comma y and z are minus 1.2 volt, zero point 0.5 volt, minus 3 volt respectively. The reducing power of these metals. So you should write the reducing power of these metals. So till here we have discussed all the questions are following the same pattern. So you understand the concept, you can answer very simply all the questions from this topic. So reducing power means it is agent, reducing agent. Reducing agent means it is undergoing oxidation. It is undergoing oxidation, right? So oxidation means which having very less value, that is undergoing oxidation. It will be a very good oxidizing agent and it is a good oxidation power also. So which on having the lowest value is it? So the third one, that is Z will having higher than first one X. The lowest one is Y. So Y will have less reducing power. So this is the answer. Z is higher, then Y will come, then sorry, Z, then X, then Y. Then moving to the next problem. Standard electrode potential for Zn Sn4 plus to Sn2 plus couple for tin 4 plus to tin 2 plus couple is 0.15 volt, and that for Cr3 plus bar Cr couple is minus 0.74 volt. These two couples in their standard state are connected to make a cell. The cell potential the cell potential will be, what is the cell potential? So tin is reducing, its voltage is given, copper is reducing, its voltage is also given. So write the values. Okay, so Sn4 plus bar Sn2 plus, and its E0 value is 0.15 volt, and that of Cr3 plus bar Cr, and its E0 value is equal to minus 0.74 volt. So what is the E cell? What is our equation? E cell is equal to E of cathode minus E of anode. So EMF of cathode means which have high reduction potential, which is higher value. This or this is negative value, so it will not come. So 0.15 volt minus anode minus 0.74 volt. So we add these two. So plus minus into minus plus, so 0.15 plus 0.74 is equal to 98. So 0.89 volt. Okay, this is the answer. Very simple. Okay, very simple questions. Don't get fear by seeing this such a big question. Okay, it's a very easy question. We are going to discuss the next problem. So the next question is, a solution contains F2 plus comma F3 plus ions. This solution was treated with iodine at 35 degrees Celsius. E0 for Fe3 plus comma Fe2 plus is 0.77 volt, and E0 for I2 bar I minus is 0.536 volt. The favorable redox reaction is the favorable redox reaction is. The question is which one will undergo oxidation? Okay, F3 plus or F2 plus or I2 or I minus. Which one is undergoing reduction? Fe2 plus or Fe3 plus? I2 or I minus. This is the question and these are the options. Okay. So here reduction potential values are given, right? So you write that one. Fe3 plus is becoming Fe2 plus. Fe2 plus and the reduction on electron E0 value is equal to 0.77 volt. Okay, E0 value and that of iodine I2. I2 is accepting 2 electron to form 2I minus and the reduction value is 0.536 volt. Okay, 0.536 volt. You compare this value which is higher value, this one. So Fe3 plus to Fe2 plus. So it will undergo what? Reduction. So Fe3 plus will undergo reduction and I2 will undergo oxidation. That is the answer. It's a correct answer. Okay. So Fe3 plus will undergo a reduction. I2 will undergo oxidation. So how we solved it? Which having less value that will undergo reduction. So here Fe3 plus will get reduced to Fe2 plus and I2 will get oxidized to I minus. Okay, same concept only. Then moving to next problem. Yes, then next question is related to EMF of the cell. So cell EMF of cell is equal to, we studied that EMF of cathode minus EMF of anode. This is equal to what we are measuring in standard condition. We are measuring a reduction potential only. So you can write that EMF of, or you can write as cathode reduction potential minus anode reduction potential. So this is the basic formula. So we can write this in another form also. So first one is cathode reduction potential. So E cell is equal to cathode reduction potential minus, so anode reduction potential. So reduction potential is opposite to, reduction potential is negative of oxidation potential. Okay. So if oxidation potential, if reduction potential of copper, suppose reduction potential of copper to plus bar copper which is equal to 0.34 volt, then what is the anode potential? So anode oxidation potential Cu bar Cu2 plus oxidation potential is equal to minus 0.34 volt. Okay, so it's always equal and opposite. So you can write that minus anode oxidation potential. So you can write this cathode reduction potential plus anode oxidation potential. This is the first form. Second form, E cell is equal to cathode reduction potential. You can write as what? Anode, sorry, cathode oxidation potential minus cathode oxidation potential minus anode oxidation potential. So minus into minus plus. So anode oxidation potential minus cathode oxidation potential. Okay, so in these two forms we can represent. So this is another question: what is the correct way of representing the EMF of the cell? Cathode reduction potential plus anode oxidation potential. Second option, what? Anode oxidation potential minus cathode oxidation potential. These two ways are also we can use to represent the EMF of the cell, right? Yes. The next question, is on the basis of following E0 values, the strongest oxidizing agent is FeCN 6 times 4 minus gives FeCN 6 3 minus plus electron, and E0 value is equal to minus 0.35 volt. Okay, minus 0.35 volt. Second equation, Fe2 plus gives Fe3 plus electronics. E0 value is equal to minus 0.77 volt. So this is how much E0 is equal to minus 0.35 volt for this reaction. Strongest oxidation. So which is the strongest oxidation? The options this one FeCN 6 times 4 minus, second option FeCN 6 3 minus, third option Fe2 plus, and fourth option Fe3 plus, which is the strongest oxidizing agent. So here which reaction is given? Actually remove loss of electron is happening, so the given reaction is oxidation. So if you write the reduction, means the first reaction reduction potential will be plus 0.35 volt, and the second one reduction potential is equal to plus 0.77 volt. Reduction, we need oxidizing agent only. So oxidizing agent, oxidizing agent. So oxidizing agent is which is undergoing reduction. So here, which is the higher value? Oxidizing agent reduction. So the second reaction. So just I am reversing, then the sign will also get positive, right? So which is the oxidizing agent? Oxidizing agent will be Fe3 plus. Okay, Fe3 plus, which will undergo reduction. So Fe3 plus is the strongest oxidizing agent. Okay, that is the answer. Then next question. So very easy only, you can answer all the questions. So next question, a hypothetical hypothetical electrochemical cell is shown A bar A plus Saltbridge then B minus bar B. Okay, concentration also you can write X comma M. Here Y at much molarity. Okay, given bar B, the EMF of the cell is of cell is plus 0.20 volt. The cell reaction. So it's another way. Okay, you have to write the cell reaction. Cell is shown here. So what is happening? What is the cell reactions? How a cell is shown like this. So the cell reaction, everything there. A is becoming as A plus. Oxidation is happening. A gives A plus. So here how many charges? One positive charge. So one electron will be losing. Second, what happened? B minus is becoming B. That means it is accepting an electron. Add these two. Electron will cancel. So A plus B minus gives A plus B. So this is the correct way of representation of the cell. A becoming A plus and B minus is becoming B. Right? This is a way of representation of cell reaction if the cell is given. Yes. Then next question, next one. So all are very easy questions only. Next question. Standard reduction potential. Standard reduction potential at 25 degrees Celsius of Li plus bar Li, comma Ba2 plus bar Ba, comma Na plus bar Na, and Mg2 plus bar Mg, or minus 3.05, minus 2.9, minus 2.71, and 2.37 volt respectively. Which one of the following is the strongest oxidizing agent? So similar type of question only. So which is the strongest oxidizing agent? That's the question. Strongest oxidizing agent means it is undergoing reduction. So it is undergoing reduction. So which is having high value that will undergo reduction easily. So see the value. The last one is the highest one. So that means Mg2 plus. Okay, Mg2 plus bar Mg. Okay, that is magnesium. Is Mg2 plus bar Mg is the strongest oxidizing agent. Okay, right. Then one more question we'll discuss. A solution of KBr is heated with Each of the following, each of the following, which would be, which would be liberate, should be liberate bromine, should be liberate bromine. So this is the question. Options are given. Options A, H2O2, option B, SO2, option C, Cl2, and option D, I2. It should liberate bromine. So which can liberate bromine, which is the very good oxidizing agent. That's a question. Okay, which is the very good oxidizing agent? So chlorine. That's answer. Chlorine can liberate. Chlorine can liberate the bromine. Okay, KBr. Chlorine is more reactive, right? So chlorine can remove. Okay, KCl plus Br. Then Br2. So this is happening. Actually, chlorine is more reactive and it's a very good oxidizing agent. It will remove bromine from KBr to form KCl and bromine. So thank you for watching.